and good afternoon, and welcome to your latest session, Security Operations and Incident Response with Azure Advanced Threat Protection. And because that's a mouthful, I'm going to call it Azure ATP from now on. So my name is Astrid McLean. I'm a Principal Program Manager on the Azure ATP team, and with me on stage.
Hi, nice to meet you. Good afternoon. I'm Eyal Manor, and I work together with Astrid at the Advanced Threat Analytics group, the group that is driving both ATA and the Azure ATP products for you. And this session, as we've promised over the past 2 days, and our session yesterday, is going to be super focused on ATA and Azure ATP. So we are going to do a deep dive and understand more what we're doing with Azure ATP, what's our strategy, our roadmap, what we have done lately for each and every one of you. So let's start. And like many of our sessions, but this is going to be a very specific and new example that you didn't see before at Ignite, I really like to start our session with analyzing a real case study of something that really happened at one of our customers. And this organization was unfortunate to be attacked. Their information were stolen. And I think that one of the worst things that could have happened to any business, I think for each and every one of us, is that their operations went down for a full 2 days. Think about the costs. Think about the reputation, about the money, about the business that you're doing if you will be down for a couple of full days. Let's understand what happened. So day number 1. This is the day where a specific computer, a specific user inside the network have been compromised. We tend to believe that this compromised computer was coming because of a phishing email, and this was starting on day 1. We can see that the attacker was running inside his computer for 3 and 4 additional months, starting to move laterally within the network. What does it mean? The attacker was actually building a map of who are the users and groups membership and IP addresses of people that they are working with. They were actually planning their step ahead and understood who are the next people that are going to compromise after the first patient. And this was really happening after 134 days, about 5 months into the attack. They actually managed to get to the system that gets them access to the funds, and they actually delivered funds from the attacked organization into the bad people. Nice. Think this is the end of the story? No. Something happened on day 135. So the attackers are hungry for more. They would like to do more. They would like to continue and do more damage and get more information and get more money. And 5 months after the attack starts, they actually deliver a virus named Wrecking Ball into 50% of the computers inside the business. Think about it. Half of the computers inside the business are down, making the entire business operations down for 2 full days. Are they doing that because they are bad? Well, yes, they are bad, but they didn't do that just to shut down the organization. They do it to decept the security operation team from the real thing that they are after, domain dominance. So see how smart the attackers are. At the very same day, they are taking half of the organization down, making sure that all security operations and people are chasing after this kind of attack, and at the same time, they are free to go to deal with the domain controller as much as they want. They started to run remote code execution commands. They've started building new users, giving them new privileges and new rights. And actually, these people by this time owned their entire domain. Microsoft Incident Response were there. They were helping them with some of the solutions that we're having. So Astrid, share with us a bit more of what we can do today for these kind of organizations.
Thanks. So Microsoft looks at their threat protection across 5 different vectors. So the first one is identities. That's kind of the new security barrier, if you like. You need to protect your identities with their users, or more particularly your admins as well. So the identities is one space. Endpoints. These are your workstations. These are the endpoints that can be, you can get malware on them. People can take over them. That's where a lot of the attackers install a lot of the tools they use to actually steal the identities to start with. All of your user data. So data that's out there, you've got a lot of classified data out there. You've got confidential data out there. That's the target for a lot of the attackers. So, looking at looking at user data, looking at the user emails, looking at the SharePoint documents, those sorts of things that you have in your environment, that's another vector we look at. And then there's all your cloud applications. This is not just Office 365. This is any of the cloud applications your users connect to. So whether it's Box or Salesforce or any of the cloud applications, we have products that can help you protect all of the information that your users use. And then finally, your infrastructure. This is all your servers and your virtual machines and databases. So it's the infrastructure that's running everything. But for the talk today, we're going to be focused on identities because Azure ATP helps to protect those identities. We'll deep dive a little bit more into that to show you what attackers are after when they're actually trying to compromise those identities. So this is what a typical kind of attack can look like. So it starts with something like a phishing email. This is something that's very common. The number of people that click on these things, even when we give them warnings, is remarkably high. They'll click on an attachment. They'll open an attachment or they'll click on a link. They'll click on a link on a website and it'll deliver malware to the machine. This is a typical way that an attacker can get hold of an identity, can get hold of information in the environment. Once they've got the malware on the endpoint machine, it means they've compromised that machine and they can start to steal information. Now, all attackers need to do is compromise one user. That's all they need to start with. Once they have one user, then they can do reconnaissance in your organization. They will, download that global address list. They will look for the IP addresses in your network. They will look for the important users. What they're trying to do is move through your environment, so move laterally through your environment by stealing user identity information and using it to gain additional privileges in your environment. Once they've got to the privileged users, typically they'll do two things. They will go and steal your sensitive data. Once they have the additional privileges they need, great, exfiltrate data, but that's not their only goal. What they really want to do is own your network. In order to do that, that's the domain dominance phase that Eyal talked about earlier. That's about getting to your domain controllers and adding additional information, adding additional users, putting on golden tickets, putting on skeleton keys, which means that even if you remediate the other users that were originally compromised, they can come back and keep attacking because that's their foothold into the environment. Now, Microsoft has a number of products that help to protect those identities in that space. So when you look at Azure Active Directory Identity Protection, that's looking at sign-in information. So any users that sign in through Azure or through ADFS, we're doing machine learning, we're doing behavioral analysis to pick up those risky users. So that helps protect you from a sign-in point of view. Microsoft Cloud App Security is our CASB product that's looking at your SaaS applications. So that once the user's signed in, that's looking at the session. So while the user is logged on, they're taking actions, they're downloading data. Heaven forbid if it's an attacker, maybe they're adding an extra inbox forwarding rule because it's another way they can exfiltrate data. Cloud App Security is looking at all of the session data to help do behavioral detections on what's happening within the session. But today we want to focus on Azure ATP. So that's looking at all your on-premises Active Directory network data. And that's where we're focusing our detections on trying to find everything that's happening within your network, everything that's happening with the users on your network, and any kind of attackers or attack behaviors that we see within that on-premises environment. And then later on in the session, we might talk about how we're going to start to bring those all together. But let's start with Azure ATP. So how many people here know about Azure ATP? All right, keep your hand up if you've deployed it. All right, not so many people. For the rest of you, look at your neighbours with their hand up. They're probably very happy. By the time you go back to work on Monday, I'm sure you'll want to go out and deploy Azure ATP. Because by the end of this session, you'll know how easy it is to do that. Is that right?
Absolutely.
Sounds good. All right, so what does Azure ATP do? So Azure ATP helps detect threats in your network. And we do that in a number of ways. We do a combination of behavioral analysis as well as understanding what known attack techniques are. So we analyze attackers, we work with our customers, we have a group of security researchers. They know what standard attack techniques look like. Now, when you combine that with behavioral analysis, the combination of both of those things helps you to reduce the false positive rate for the detections. Because if you have thousands of detections, your poor security operations team is going to be overwhelmed. So what we're trying to do is deliver you a set of detections that are clear, that are focused, and have the lowest false positive rate that's possible. We also present the information to you in a clear timeline format. So we want to give you an idea of what's happening in the system, when it happened, and give you clear indications of why we alerted, what evidence we had that this was an accurate detection, and give you steps in order to investigate and remediate that. Now with Azure ATP, we do all of our detections within an Azure service. So the fact that we can use a cloud service means that we can scale from the smallest organization to the very largest organization. So it's very easy to deploy. You just need sensors on your domain controllers on the network. That sends data up to the Azure ATP service, and that's where we do all of those detections. And of course, like all good Microsoft threat protection products, we're getting threat intelligence information from the rest of the Microsoft network. So we're using the power of the intelligent security graph to add intelligence to those detections to make them as accurate as possible. That's just a summary of what Azure ATP does. So let's look at some of the detections that we do. So Azure ATP looks at the full scope of that kill chain. When an attacker comes into your environment, they've compromised that first user. They're going to spend some time in your environment getting some idea of who are the other users in your environment. What are the IP addresses? What are the servers and the privileged users that they want to go after? It's like building a map. They want to know where they're going before they go there. So they spend some time in the environment doing reconnaissance. Now, a lot of the detections that we have in Azure ATP help you find some of those very early attack techniques, help you see when an attacker is starting to do that reconnaissance. The idea being that if you can catch the attackers much earlier in the kill chain, it means you have a much better chance of stopping them from doing what they're doing. So the reconnaissance techniques and the ones we found help you stop things happening very early in the environment. But as they go forward, they're going to be compromising more credentials. We will look for signs that a particular identity has been compromised. So whether that's something like just a brute force attempt, we give you information in the system that says these are the accounts that were attacked, these are the ones that were successful. We also give you a list of the ones that were not successful. Because in Azure ATP, it's all about understanding what the attacker is doing, so whether their techniques are successful or they're not, they're still showing up in your environment, and we want you to understand that. We also have information from your radius accounting logs. So our information primarily comes from the network, but we will take VPN information, and we can show you information like a suspicious VPN connection. So this is a way that we've seen attackers get into the network. They find, kind of a VPN connection, and they come into your network. And by understanding the users in your environment, what their usual behavior looks like, we can start to tell you when there is a suspicious VPN connection, which is an indication of a compromised user. Now, as the attackers are moving through your network, they'll use a number of lateral movement techniques in order to do that. And some of the common techniques are things like pass the ticket, pass the hash, or overpass the hash. The idea being they don't need the user ID and password of a user. If I can compromise a machine, if I'm on your network, I can steal credentials from memory. I can steal a Kerberos ticket. I can steal a password hash. I can take that and impersonate the user on the next machine and compromise yet another user. So these are techniques that we understand because we're profiling the users, we're analyzing the network traffic. We can alert on when a Kerberos ticket is being used inappropriately or being used in a different way. We can also look at things like protocols in the environment. So if we see the SMB protocol being used in a way that's not the normal way of doing it, so we analyze things like SMB protocols, Kerberos, so we do analysis of all the protocols, and we'll also alert on techniques. So some of the recent kind of ransomware like WannaCry, the signature for that was really misusing one of the protocols. That's something we can detect because we analyze the network traffic, and we analyze that in real time. So you see the detections very quickly. And then finally, if the attackers have gotten to your domain admin account, so they've gotten to the domain controllers, there's a number of techniques that attackers use to control your domain. Things like putting a golden ticket or a skeleton key on there, or even doing a remote code execution on the domain controller, where they're trying to connect to it remotely, to run services, to run programs on the domain controller. These are all known techniques for an attacker owning your domain, and we will alert you on those things as well. So, is it easy to deploy? Absolutely. It's very easy to enable Azure ATP as a service. You then just need to deploy an Azure ATP sensor on each of your on-premises domain controllers. Now, we know this is a very easy thing to do. When Microsoft customers have a potential incident in their environment, they can call Microsoft and we have an incident response team that can come out. The incident response teams, one of the first things they do is deploy Azure ATP in the environment. Because even if an attack has taken place, typically attackers will stay in the environment. We will see the behavior. We will see what's happening in the environment. And so the attack that Al talked about in the beginning, when Azure ATP was put into the environment, those were some of the techniques that we saw because the attackers were still in the environment. So Azure ATP primarily looks at the network traffic to and from the domain controllers. We will analyze that traffic. So unlike products that only look at logs, we're doing real-time analysis of the network traffic. And so we can detect very quickly. We will get additional information, things like the VPN information I talked about, the radius accounting. We will look at some Windows events that are interesting to our detections. And we're also starting to look at event tracing information that we can get directly from the domain controllers, because there's a wealth of information that we can understand the protocols and we can understand what attackers are trying to do based on the real-time information that's coming from those domain controllers. So not only do we monitor those activities, but we also analyze user behavior environment, so we can determine what is abnormal and what is normal behavior, so that we're not alerting on everything, just on the abnormal behavior. And not only do we detect and alert, we also give you a platform to investigate and help you to respond to any of these attacks.
And many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we understand. Many of you are coming to us to the Azure ATP booth and you're saying, okay, we're understanding how it looks like or what you're doing and of the attack hill chain, but show us how it looks like. So first, I really want to thank each and every one, maybe from these people who are coming to the booth and who are asking questions and we're giving feedback. This feedback is super important for us and we're always there for you throughout the rest of the week. But let's really take the time now to see how Azure ATP looks like. What an alerts look like, what we're identifying. Think about security operations experience or response people who are coming into an organization in order to identify an advanced attack. How would it look like and how it will look like? So this tenant here is actually bringing all of the goods from Azure ATP into the detections. We can see that I'm logging in to the Azure ATP investigation portal or alerts portal. And the first thing I'm getting to see is actually you can see your alerts such as domain dominance for golden ticket attack. and several other compromised accounts. But what we will do today is that we'll actually go all the way to the end, and we'll actually take a look at the very alert that Azure ATP has identified. So let's give a deeper look at that. So Azure ATP have identified an alert named suspicious VPN connection. Let's delve into this alert and see what it means. So suspicious VPN connection, as Astrid has mentioned, everything we're doing today in Azure ATP, it's all about identities. Our mission and our goal is to learn everything that the identity is doing, how the identity behaves. For example, Astrid, what devices Astrid you are connected from, what kind of resources you are using, what kind of servers you are RDPing to, what kind of resources you consume, how do you usually connect via VPN. And if I'm not talking about Astrid, but about our hero, Jeff Lederman, which is one of the patient zero in this organization, we can see that Azure ATP is learning the VPN behavior of Jeff Lederman. So what we are learning is when Jeff is usually connecting from VPN, what are the names of the machines that Jeff is connecting from, and what kind of locations Jeff is connecting from VPN. This is something that we are learning in addition to the domain controller sensor that Astrid have mentioned. We are learning that by actually connecting to the radius accounting data, so it's pretty much not relevant to what VPN vendor you'll be using as long as they are sending data to the RDP accounting. We'll be taking that and actually looking at that in order to understand more about the user. So why have we raised this alert? And here you can see the evidence part. The evidence part is relatively new. So before the evidence, we see the attack name or the alert name, some description. We can see some involved entities, but very important and very relevant aspect here below is actually talking about the evidence. So Azure ATP have raised these alerts because of two things. First, we see that Jeff Lederman normally doesn't connect from Manila, Philippines. The second, we see that Jeff was connected from a computer named Lenovo T470S, and usually we haven't seen Jeff connecting from that before. So 1 + 1, plus everything that we know about Jeff, is actually triggering this alert. Now, think about security operations. We would like to understand who is Jeff. Maybe it makes sense. Maybe this is the first time. Maybe Jeff got a new computer and now working from Manila, the Philippines. What we'll be doing is that we'll drive or drill down into the identity of Jeff, and let's understand to be a bit more familiar with Jeff. Who is this person? What does it do? Does it worth continue to investigate that, or maybe we can just close this attack, close this alert, and continue to the next one? So let's take a look at Jeff. So Azure ATP gives you all of the information that we can about this identity. So here is Jeff. Jeff is a financial accounting manager. He works for finance. I know at my business that we don't have a finance department in Manila, and our financial people are not traveling that often. We can see here that we have several tabs. So one of them talks about directory data. Let me click on directory data and see whether we get something helpful here. So we can see some more information about Jeff. We can see exactly what groups Jeff is belonging to. So we see he's a part of finance. He's not a very sensitive account. I'm not sure how much we'll get out of Jeff. We can see the organizational structure and some more information about how the account is currently configured. I see that password is never expiring, but also we learned this morning that it's good that password never expiring, but this is a totally different story from Azure ATP today. But we learn a lot about Jeff, and as a security operation engineer, I get into the conclusion that the VPN connection from Manila, Philippines, for Jeff, which is a financial person, doesn't sound amazing. So let's see what we can do more and learn about Jeff. So I will click at the Activities tab. And when I'm clicking on the Activity tabs, I get to see more information about Jeff. What computers Jeff is using, what resources Jeff is accessing, how many locations Jeff is connecting usually from. And we can see here in a very clear way a list of all of the activities just Jeff was doing. Keep that in mind, because right now what we're saying here is that we're saying many activities that happened in the on-premises. We'll be talking a bit later about our roadmap and strategy, and you'll see a very, very nice surprise that we're preparing for you for today. But right now we're talking about on-premises aspects, what Jeff is accessing to in terms of computers and VPN and RDP. And if we drive a bit below, we can see that we have more alerts about Jeff. So the identity name Jeff didn't just enter to the business from a suspicious VPN connection. It also had several alerts related to Jeff talking about reconnaissance. So Astrid, we talked about reconnaissance and building a map, understanding who are the users of the business, what are the roles, what are the IP addresses, and this is exactly what we can see here. If we delve into the using account enumeration, the account enumeration is showing me a lot of information that Jeff was actually trying to see what are the usernames at the business. So we see that it tried many usernames, Astify and Accused and Bonnie and so on and so forth. And these users do not exist in the Active Directory. One of them, Lydia, does exist in the Active Directory. So we know that Jeff is trying to build some kind of a map. There is another reconnaissance alert talking about directory reconnaissance. So directory reconnaissance will help Jeff understand what kind of users and what kind of group they belong to. So Jeff managed to understand there is a person named Lydia. We saw that he managed to enumerate Lydia before. Now he knows also that Lydia could be a part of domain administrators. So as we see the plot getting thickens, we know that Jeff was coming from a bad VPN location. We know that Jeff is trying to compromise the user. I don't really trust this identity. So let's see what else we can do with Jeff. Let's open Jeff's page again. Here you are. So for a moment, I can stop here. I can go to the SecAdmins, or I can do some activation for several actions on Jeff, because I know for sure that Jeff is compromised. So maybe I can reset Jeff's password. Maybe I can require some more authentication. Maybe I can disable the account and wait for Jeff to call back to help desk. Maybe we can call Jeff because we have his phone number from the directory data and understand if he's familiar with that. So we can already take some kind of remediation. But since we are very good security operation people, we would like to think forward. So if we remember and if we are thinking about this place that was compromised from some 30 minutes ago, we understand that patient 0 was not the target. This person was not sensitive. The attacker was attacking somebody in order to attack another one and another one and another one in order to really gain privileges account, in order to get domain dominance. So for that, Azure ATP brings an amazing security concept called the lateral movement path. What we would like to do here with the lateral movement path is that any security person here can try to understand from Azure ATP what potentially other identities Jeff can compromise in order to get to the jackpot, in order to get to the domain dominance. So the lateral movement path is working in a way where Azure ATP will try to understand what machines Jeff has an admin privileges on, where he can connect as an admin, and for which, for the same machine, what other users can log in. There are methods that give me the ability to log into my machine as an admin, and if Astrid will do some remote desktop or some other log on to this device, I will have some methods and some abilities to actually steal her identity and use it from another device, and nobody will know about it. Almost nobody. So you can see that from Jeff, I can actually jump to a person named Ron. Ron is not sensitive as well, but the graph is not finished because from Ron, I can jump to Nick. And Nick is the domain admin. So think about us. We would like to be prepared. We would like to think one step before, one step ahead of the attackers. And we understand that Jeff can get to Ron. Ron can get to Nick. So already here, there are two options. A, maybe we are late to the game and the attackers before us and already got to Nick. This is the case that we are going to demonstrate. But the other case, which is more the proactive case, is that we will understand that before the attackers, and now we will be able to make sure that Nick does not use his credentials to connect to SharePoint SRV, or maybe make sure that Ron, which is a part of the help desk, will not be administrator on SharePoint SRV, and by that actually cut the loop and make sure that our business gets by far more secure than ever. So let's continue our story, because Astrid, you asked how Azure ATP works.
I did.
Interesting so far?
Very interesting.
So the story never ends here. So we know that Nick is compromised. Let's see whether we're smarter than the attacker, or whether the attacker is smarter than us, and let's see what's going on with Ron. So we see Ron here, and there are some activities for Ron, but let's take a look at that. So the attacker was faster than me today. And actually we see that there is an alert talking about past the attack, or past the ticket attack on Ron's identity. So let's try to understand what does it mean. Let's click on that and take a look at the alert. Past the ticket attack is one of a complex, very sophisticated, very hard to detect attack that Azure ATP is very, very happy to detect and provide you the information with. As we can see, there are 4 involved entities, and this makes the story a bit more complicated, but let's try to understand what happens. So on the left, we can see Ron. Ron is the user, and on the right, we can see 2 more servers, Finance SRV 53 and RDP SRV. What it means, and what we can see here, and what we can see in the description, is that Ron was logged into Finance Server 53. And that was valid, and that was good. And Finance Server 53 had Ron's identity over there. But then, like magic, we've seen Ron's identity logging from RDP SRV. And we know that Ron was never using RDP SRV. And this doesn't make a sense. So when we see an identity logging in from one computer, where this identity never used before, but it was using the same identity from another computer, this gives us the ability to believe that something is fishy, is running here. And we can see a lot of the information back at the evidence. As we said, the very important element in the alert that provides security professionals, incident response people, security administrators, SecOps administrators to understand what happens. And we see that the Kerberos ticket was first observed on Finance Server, and we know that Ron was never observed logging into RDP SRV. So when I'm looking at that, 2 things come on mind. First, I know that Ron was compromised as well. Let's make some actions. So we have Nick compromised, remediated, Ron compromised. I will deal with him in a moment. But I know that those servers, those devices, they could have been compromised as well, right? I don't really see a chance that somebody took Ron's credential from Finance Server without this device being compromised. And for that, as Astrid, you showed before, Azure ATP is not a standalone solution. It's powered by the security graph, and it can connect to Windows Defender ATP. And we would like to provide you the ability to tie the notes together. So let's take a look at this computer, Finance Server 53. And as you can see here, we have the ability to see that Windows Defender has actually found the alert on this device. I can actually click, and I will be moving to Windows Defender, and I will get right on the spot, seeing the Finance Server number 53, and we can see that Windows Defender has really understood that this device is doing some bad things. Now, I will say something a bit more than that. Of course, that at Windows Defender, you can now continue and do your drill and actually remediate this computer, but Windows Defender also have the automatic incident response elements that will actually remediate these things automatically for us. So one of the integrations, additional integrations that we will actually introduce in the upcoming future will be that when I'm seeing that, I will already have the ability to see that Finance Server 53 and RDP SRV have already identified as compromised by Windows Defender. They were already remediated. I will see them like in a very nice checkbox, and I don't need to do more than that. So indeed, as we've seen in the past several days, we are driving to automation and driving to make security operations processes by far more effective, more easy, more automatic. So these are elements that are very, very nice for us. So we talked about Ron. If you remember, when we looked at Jeff, so we saw that Jeff can jump to Ron, and Ron can jump to Nick, right? So let's try to see also if here we are ahead of the attacker or behind the attacker. I think, Astrid, you are behind the attacker here as well.
I don't like our chances.
So, yeah. So we were at Jeff, and we had the lateral movement path. Let's get it up and running. And let's see what we know about Nick. We know that Nick is a security administrator. And let's open Nick's page here.
Hey, Al, what makes Nick a sensitive user?
Oh, you're talking about this tag?
Yeah.
So this tag is showing us that Nick is sensitive user. And specifically here, Azure ATP have chosen automatically to mark Nick as a sensitive user because he's a part of the domain admin group. One of the things that Azure ATP gives you is the ability to use whether automatic or manual assignments. So you can actually tag your own groups as sensitive people, even if Azure ATP doesn't think that they are sensitive. For example, maybe because you have any proprietary names for specific groups marked as sensitive. So let's take a look at Nick here. And if I will actually go and see Nick, then, oh boy, Nick got compromised as well.
Yeah, it doesn't look good.
Doesn't look good. So they compromised Jeff, moved to Ron. Now they've moved to Nick. And remember, Nick is an administrator, meaning that very, very soon, the bad guys are going to dominate my domain controller. And this is something I don't want to have. So let's see what Azure ATP have identified here. So we have another pass the ticket to Nick. And we can see several more elements. So let's take a look at several more alerts that Azure ATP have identified, starting with remote code execution attempt. So Azure ATP actually identifying any remote code execution that are done on the domain controller. And we're not only identifying that there was a remote code execution, but also exactly what command was run and who the user and what was running in the background. And what we're seeing here is actually following the real case study that I was showing at the beginning of this session. So all of the examples that you see here, of course, that this is a demonstration tenant, but all of them are following one by one exactly to a specific flow that our incident response people have actually identified in the field. So everything we are seeing here is actually providing elements that really happened in reality. And we can see several additional aspects that were coming later from Ron's device, from Nick's device, such as, for example, encryption downgrade activity. And as we know, and as Astrid said before, Azure ATP is actually monitoring what kind of encryption protocols are used between different users and different computers into different resources. And we've identified that there was a specific encryption protocol that was suddenly downgraded. And we are marking that. And in this case, we have the ability to know that this is a potential skeleton key attack. Continue with sensitive modification, suspicious modification of sensitive groups. And let's understand what it means. So Astrid was saying that we are monitoring traffic on the domain controller, but we're actually monitoring by far more than that. We're trying to look whether people's phone number, whether people's title, whether people's group belongship, whether people's manager is changing in a suspicious way. It will not make very sense if Astrid's phone number will be changing 5 times over a period of 24 hours. And in this case, it doesn't make any sense if, as we can see here, Nick haven't been any time modifying the administrator group, but just specifically yesterday, he was actually taking a specific user named Moni and actually added her to the administrator groups. Now, attackers are doing that because they know that one day they are going to catch the admin user that they're doing and remediate it. So let's ensure ourselves and back up ourselves and add more users and add them to the administrator groups. So if this one falls down, I will have another one or another one or another one. So attackers are not really believing that they will have just one identity and everything will be fine. They are actually trying to ensure themselves. So the plot continues, and we can see that Nick was trying to replicate the directory services, and at the end of the day, actually gain into a golden ticket, which is starting this moment, giving him any ability to grant tickets and technically authenticate on behalf of any user. So let's try to finalize that and understand that many of those elements that we've seen here could have been prevented before. If we have identified the suspicious VPN connection coming from Jeff on day one and starting to look at the lateral movement path and secure ourselves and start to cut wherever we have the ability to jump from one user to another user, we have the ability to avoid that. Or if we were to track Azure ATP alerts over time, we had the ability to see that something suspicious is happening and make sure that we avoid the domain dominance element.
Just before you go back.
I know what you're going to ask.
You forgot my favorite feature.
Yes. So, Astrid, thank you very much for that reminder. Because we would like to show you another very, very important feature, and I appreciate that, Astrid. Another very important feature that we are having in Azure ATP that is called the honey token. Think about decoy accounts. It's very interesting for us to see that in the decoy world, Azure ATP gives you the ability to actually set a couple of users in the system. And let's say that these users are having interesting names or interesting group membership, or maybe they are signing in to several interesting locations, but of course there is nothing in between, nothing inside. These are just decoy accounts that you will be configuring and let us know that these are honey token activities. The very important and interesting element is that we can believe, and you can believe, that at the moment that there is, in this case Lydia, is our honey token, she is a domain admin, and we can tend to believe today that any triggering, any activity, whether it will be reconnaissance, whether of course it will be a login activity, or any activity more than that, that will be relevant to this person, will be referred to a honey token, will be referred to compromised credentials, and from that we can actually go back and understand that there are other devices that were actually taken or other users that were taken. So thank you for that, Astrid.
Thank you. Thank you for that good demo. So
I really, really hope that this demo shed more light for you on Azure ATP and what you're doing. Really hope that you liked it.
All right, so let's just recap quickly what Al kindly went over. So we have that simple alert timeline. So all of the alerts have good information about how we can, what evidence we had for the alerts, what you can do about those. We talked about the honey tokens and the sensitive accounts that you can tag manually in your environment. We'll automatically, tag sensitive accounts for the admins, but you can expand on that. And we showed some real-life detections based on compromises that we've seen in the wild. You also saw that it's not only detections, it's also investigation. So you can look at the user activities through that user profile page, you can look at the user behavior, and importantly, you can use the lateral movement graph to try and understand what attackers can potentially do in your environment, and it gives you the opportunity to get in front of what attackers could be doing and cut off some of those connections before they can get to some of your sensitive users. What we found is for a lot of the Azure ATP customers, when they deploy Azure ATP, as well as looking for detections, it helps them understand where there is potentially bad behavior in the network, simply from administrators not doing the right things, or apps not doing the right things. We have apps that are passing, passwords in clear text. We have hashes that are being moved around. So you can pick up that kind of bad behavior, because I can tell you, if it's happening, the attackers will find it as well. So you're much better off if your security operations people can see that with good visibility. And we also looked at our connection to Windows Defender ATP. So when I talked about the different elements of the threat protection story, and we talked about identities and endpoints, there are relationships between them. And Azure ATP allows you to inspect what's happening on a device using the behavioral power of Windows Defender ATP, and allows you to seamlessly move between those two products as your security operations team is investigating any of these incidents. All right, so Azure ATP, it's young, but it's kind of old. So we released Azure ATP in March of this year, so it's been out for 6 months. But it's not an entirely new product. The intelligence behind it was born from a product that we still have in the market called ATA, and we'll talk about ATA a little bit later in the presentation. So it's a new product with a lot of kind of intelligence behind it. So how's it been going in the last 6 months? Fabulously, actually. So we've had a lot of customers deploy Azure ATP. Azure ATP is currently protecting millions of users. One of the comments that we get often from our Azure ATP customers is this is so easy to deploy. It's very easy to put it on your domain controllers and start to get value very, very quickly from Azure ATP. So it's deployed on thousands of domain controllers. And we have it, of course, deployed protecting Microsoft's assets as well. So we've deployed it internally because we have the same potential attackers as every other organization, and we want to use these tools to make sure we're finding what's going on in the environment. Now, Azure ATP is also used, as I mentioned, by our incident response team. So when the incident response team comes on site for a customer that's had a problem, one of the things they deploy is Azure ATP, and they can deploy it very, very quickly. And what we found is even after an attack, so even if you haven't already got the product running, after an attack, they still see attack behaviors. Attackers tend to stay in the environment. We see that domain dominance information. We see lateral movement in the environment. So while it's best to put Azure ATP in your environment to protect it up front, even if there is an attack in your environment, and most companies have been breached or will be breached, it will still give you a lot of value, from day one, as well as ongoing monitoring. Now, in terms of speed of deployment, I think our fastest deployment so far, 800 domain controllers in 1 day. And so from a deployment point of view, it's very easy to get the sensors out there. It's not a heavyweight product that takes you a long time to deploy. Now, we've been out for 6 months. It's easy to deploy. We've got it out in a lot of places. We made any improvements?
Yeah, so we're making improvements actually in the speed of the light. We're 7 months or 6 months old, and we actually managed to provide improvements to Azure ATP almost on a weekly basis. Think about that. It's an enormous number of times that we have the ability to actually push new updates and bug fixes and make improvements and introduce new security features. And we would like to take several moments just to share with you several of the greatness and good that we've done over the past several months. So we can think about them as how we make security operation work more effective, how we can make the product more secure, and how we are also helping the domain administrator work, the people who are deploying the solution, how we can make their life even simpler. So let's take a look at how we can actually simplify the investigation experience. And I will just show here a couple of examples to see that we're learning a lot from everybody here in this room that is using Azure ATP, other people that are using Azure ATP. You have the ability to send us feedback at any point of time, and we can learn, and we'll get engaged with the people. And in this case, we understood that, for example, the encryption downgrade was a very generic alert. It was hard to understand what it was exactly meaning. So we actually learned a bit more and added the research and started to understand that encryption downgrade can actually refer to several elements, such as, for example, potential golden ticket attack or potential skeleton T attack, and we actually split these to several different alerts. More than that, you can see the evidence at the bottom part of each of every one of these alerts. This is something new that we've recently added that is giving us by far more information and more evidence explaining us what happened. So we talked about encryption downgrade, but this is the same pretty much for unusual protocol implementation. What does it mean? If we're listening to Kerberos traffic, listening to SMB traffic, we're actually expecting to see a specific pattern as the standard has been written. So a legit program will usually talk according to the protocol. Sometimes unlegit programs are actually make some changes to the protocol, and it gives us the ability to understand that something bad is happening on the network. So for example, at the top of the page, we are now recognizing WannaCry activity. We actually recognized WannaCry activity when WannaCry was there.
Yeah.
We just didn't have enough ability to tell you that this is WannaCry. So we had to continue our research and to continue with that, whether we are recognizing Metasploit or whether we are recognizing other malicious tools such as Hydra. So all of that is coming to really help investigation process to become faster. So you don't need to be dependent on the security alerts guide. So you'll not be dependent on maybe somebody from Microsoft that will be helping you, but really give more independence and more ability to really run quick and have the security operations process by far more effective. So this is about effectiveness. Let's also talk about security. So we're not stopping with security. We continue to make tons of research every morning, every evening, every day. We're adding a lot of detections, starting with golden ticket. We've been identifying golden ticket based on time anomaly. Today we're also identifying golden ticket based on a user that doesn't exist in the system. So maybe Astrid here can perform some golden ticket, and now she needs to have her victim. She needs to know what user to use and provide the tickets to this user. The attackers not always make sure that this user will be indeed a valid user that exists on the domain controller, and if this user doesn't exist on the domain controller, we'll actually tell you, hey, this user, and you can see it's like in dotted lines, this user is not in the system. We don't know this user. Continue with another detection that we have added to actually identify an attack that was published just earlier in 2018 called DC Sync, DC Shadow. And DC Shadow attack is actually giving the attacker the ability to take just any innocent computer, it doesn't even have to be a Windows server, and actually to pretend that this computer is domain controller. What they are doing is that they promote this computer to be a domain controller, and with a matter of split seconds, they are doing something bad. They are changing some directory objects in order to control better of the users or their group memberships, and disappear. Take this computer and do demote. This happens maybe in 1 second. And as we can see here in the evidence part, since we are looking at the networking part, since we are working in real time, we can actually identify this evidence. And we can see here that we are identify those elements and see the DC Shadow attack, whether we are finding it here from domain controller promotion or demotion, or here this is another flavor for this attack that is actually understanding that there were changes in the directory objects. So we were talking here about 3 domain dominance attacks. Also the VPN, which talks about compromised user, that we've analyzed this attack a few moments ago. Because remember, this is how Jeff Leatherman allowed the bad people to get into the business. So this is also a new attack that is really helping us to analyze and understand how people are working and connecting from VPN. So we're not stopping here. Very soon, you're going to see additional reconnaissance elements, for example, that are coming through the LDAP protocol, not only using the protocols that we are covering today. Compromised credentials, brute force attack, we are improving that and building also mechanisms to identify password spray attack, and also additional elements that will provide you more information about compromised accounts. Continue with suspicious DNS communication. We are listening to the DNS communication, and we understand whether devices are talking to a command and control channel, or whether identities are trying to exfiltrate data through DNS, and we're actually going to provide this information. We're going to add additional flavors for golden ticket. We're going to understand whether was there any sensitive data that was exfiltrated for the domain controller, and we are making a lot of enhancement and remote code executions. All of that are coming. So these are talking a lot about security elements. It's important for us to think also about the people who are deploying the sensor on the domain controllers, and we're working very hard for these people as well.
So, in order to help the people that are managing the sensors, we have an automatic update process on the sensors. So as we update the service, we automatically update the code on the sensors so that they're up to date. One of the pieces of feedback that we got from particularly some of the larger customers is they didn't want all of their sensors being updated at exactly the same time. So now we've introduced a new capability called Gradual Sensor Update that allows you to mark a group of your DCs or a group of your sensors to be updated slightly later than the rest of your sensors. So if you've got a large deployment, you may want to choose a group of domain controllers or sensors that are either particularly busy or in a different environment, and have those updated slightly later, so not everything is updated at the same time. And we've got a lot of positive feedback from people that said, thank you, this is what we were looking for. We wanted a ring type approach to say, hey, we actually want to update things a little bit slower. One of the most anticipated features we had for Azure ATP was multi-forest support. Now, it turns out that most organizations have multiple Active Directory forests. And while we may manage them separately, attackers don't care. Attackers will quite happily take a Kerberos ticket from one forest, use it in a trusted forest to continue their lateral movement between forest boundaries. So now we have support for multi-forest within Azure ATP. You can have all of the domain controllers for all of your trusted forests reporting up to the same Azure ATP instance. And not only do we look at the domain controller traffic, but we also have detections which cross forests. So because we're looking at all the traffic, we're profiling all of the users, all of the computers, we're analyzing all of the Kerberos tickets, we can see attacks that are happening between Active Directory forests. And so while this has been in private preview for a little bit, this will be released this week? Today?
This week, yeah.
This week. There you go, with the next deployment. So this will be available to all of our customers.
But we already have many dozens of organizations that are working with the multi-forest.
Yes. Yes, because it was a very keenly anticipated feature. It's like, give it to me now. All right, so they're not the only things we're doing. So they're the things that have been released. These are the things we're working on that are helping to improve the deployment and the management of the system. So the first one is the lateral path improvements. So you saw how valuable the lateral path, the lateral movement path can be as part of your investigations. Now the way that the feature currently works, we only keep those lateral movement paths active for about 48 hours because it's something that can change over time. The feedback that we've had from customers is even if it's not a valid path today, when I'm doing my investigation, I'd like to see what that looked like 10 days ago or 3 weeks ago. So to help with the investigation, we're looking at providing a history of the lateral movement path so you can use that as part of your investigations to see what lateral movements might have happened or were available in the environment. The second thing we're looking at is making sure that people have complete coverage of Azure ATP. Azure ATP is most effective when all of the domain controllers in your environment are covered by a sensor. Now, it turns out that sometimes the security operations team and the infrastructure team don't always talk, might not have the best communication, so they install another domain controller. Oops, I forgot to install a sensor on that one. So what we're making sure is putting an alert out there to advise you when you don't have full coverage in your environment, which means you may have gaps in the traffic. When you have gaps in the traffic, it may affect the detections. So we're trying to give you information to make sure that you have the most effective coverage of Azure ATP in your environment. Now, similarly with our user roles, today we have kind of viewer, user, and admin roles. The user role is most effective for your security admins. They're the ones that can look at the alerts. They can open, close them, those sorts of things. We want to make sure that they've got additional permissions to do the things that are important to them. Things like adding an exclusion, marking a user as sensitive, or marking a user as a honey token. These are all activities that are typically something the security operations team does. So we're looking to bring those privileges to those users and leave the admin users to manage the sensors, because we've seen that it's a better split of responsibilities between those two teams, and we want to make sure that the security operations team is as effective as possible in their jobs they're trying to do. And then from a deployment point of view, while Azure ATP is very easy to deploy, there are 1 or 2 steps at the beginning that we've realized that we can do automatically on behalf of customers. So for customers that haven't yet deployed Azure ATP, it's only going to get easier as we start to automate any of those initial steps for the deployment.
So this is a beautiful progress just in a period of 6 months.
It is.
And we continue to work very, very hard with Azure ATP. And we would like to take just a very few moments in order to show you just what we're doing in our strategy. So back today in the morning, there was a session, 9 a.m. for security and identity. Yesterday there was another session, and since our time is running, we will make a relatively quick review, and you'll be able to refer to the morning session to see what we are driving today when talking about Azure ATP. So, looking at our solutions today, the identity solution, Azure ATP, Microsoft Cloud App Security, Azure AD Identity Protection, all of these solutions are actually handling identities. They learn identities. They understand identity behavioral. Azure AD Identity Protection, looking at sign-in sessions to the cloud. Microsoft Cloud App Security, inspecting the application sessions in the cloud. As we see for the past 1 hour, Azure ATP is looking at subnormal activities, suspicious activity on the environment. But when we are looking at that, we do understand that attackers do not think like, hey, we have Microsoft Cloud App Security. Let's attack them in the cloud, right? So they don't think like that. They think about reality, and in reality, everything is a mix. And then the question is how we can make it better for you. How we can actually look at all of these 3 solutions and unify everything we know about identities to give you the ability to look at a single pane of glass and to say, this is what I know about identity. And this is what we are introducing today. It's still a roadmap item. It will take us a couple of months to launch it for preview, but stay tuned. But what we're doing right now is that we're building for you a single security operation experience that will help you understand what is the entity named identity. Everything Microsoft you know about identity, show it to me. We're building also cross-correlating events and alerts. So if Astrid did something bad a bit in the cloud, and not bad, but suspicious in the cloud, and a bit on the on-prem, both together we can raise an alert that cross-correlating those dimensions. And these are very unique. And not only here, we're also working on a capability that will help us understand that maybe Eyal that is compromised and Astrid that is compromised, both of us are compromised equally, but maybe Astrid has more access to more sensitive resources, maybe she's managing more people, maybe she's more an executive in the organization, she has further access to the crown jewels, so we'll prioritize Astrid on her. So we're going to take here like 3 or 4 minutes to see a very, very short demonstration. If you want to see the bigger, the longer version for that, refer to the 9 a.m. session about protecting identities on cloud and on-prem.
So we're going to start here. This is the Azure Active Directory Identity Protection console. So this is where you can see users that have been marked as at risk as part of their sign-in. So here we've got poor Jeff Leatherman, who's our standard user that seems to be, he gets compromised on a regular basis. So we can see that he's marked as high risk. We can see here from an Azure AD perspective that his credentials have been leaked, which means we found his credentials somewhere on the dark web. We matched them back to Jeff. So we know that his user identity is a potential to be compromised. And what we've added here is a link to say, hey, I've now seen a potentially compromised user. How can I see what's actually happened in my environment? So I click on the link to Azure ATP or investigate with Azure ATP. It takes me into a new user console that shows me all of the information I have for this user. It'll get there. With all of the information from, or not, started to do this a little bit. All right, we'll just go and find him manually. It will show you. There we go. Here's our page of Jeff Leatherman. So it's showing me all of the information we understand about this user from both the cloud activities as well as from the on-prem activities. So, as I all mentioned, we have a new concept called an investigation priority. What this does is it helps you understand how important it is for you to investigate this user. And we calculate that score based on a number of things. What we know about the user, how important they are in the environment, what alerts we've found for that user, and that's the alerts we've found across the cloud and on premises. And almost more importantly, we're also looking at the activities of the user. So anything we consider as a suspicious activity. And any abnormal activity on its own may be too low fidelity to generate an alert. However, when we combine those unusual activities with our alerts and with what we know about the user, we can generate a very fine-grained priority to say, this is the user that could be compromised and you really need to do something about this. Now, we also provide information like what devices the user has used, what the latest device is, what the common device is, what locations they connect to, what resources they connect to, and also if they have multiple accounts. And all this information comes from our cloud sources and from on-premises. And when you have a look at the alerts, you can see the types of alerts that we show you about this user. So the leaked credentials and the risky sign-in come from Azure Active Directory. The suspicious inbox forwarding is actually an alert that comes from Cloud App Security. That's looking at the cloud session, and we know that something has happened to this user's inbox and somebody's added a forwarding rule, which is a technique that hackers use to exfiltrate data. We give you information about abnormal access to protected data. We can look at the data, we understand what is classified, we can see what is normal and what is not, and we can alert you if there's an abnormal number of classified documents that this user is suddenly starting to use. And then we see the on-premises detections that you saw as part of our demos, things like the reconnaissance and suspicious VPN. So that's a very quick overview of what our new page looks like.
It is a beautiful overview, and I love it, because now we can look at identities and understand exactly what's going on with identities and whether they are going on the cloud or on-prem. And thinking about that, Astrid, we are talking a lot about what we have today. We just touched based on what we are going to do. You started by asking how many people here are using Azure ATP, how many are familiar. Not everybody is using Azure ATP. What would be the best advice, Astrid, to start rolling out Azure ATP, let's say on Monday, 9 a.m.?
So when you get in on Monday, 9 a.m., this is what you want to do. You want to start by deploying Azure ATP to protect your primary user domains. So these are the areas that you have the most identity activity. You can set those sensitive groups, set those honey tokens, and you can start to look at the reports and those lateral movement path reports in the environment, even just to get not only a feel of the detections you see, but also how well your environment is configured. It gives you a wealth of information. Next, to go forward, we want you to protect all of your domains and forests. Look at those alerts and look at our suspicious activity guide. We provide a lot of information about the alerts, how you should investigate it, and what the remediation should be. And lastly, make sure you integrate it into your security operations flow. If you already use a SIEM system, you can take our alerts, send them out to the SIEM. What we often see is that the security operations folks can then come back to Azure ATP to do the investigation.
Sounds like a plan.
It is, but we've been talking all about Azure ATP.
Yeah.
That's not the only product we work on.
That's right. We're parents to two products.
We are. What about ATA?
What about ATA? So first, let's see here in the cloud, in the crowd, cloud, on-prem. Advanced Threat Analytics in this audience. Who is using Advanced Threat Analytics today?
Few.
Oh, over there. Hi there, guys at the back. So we would like to spend just a few moments, and since there are just few, I will say seconds, because the number of the people here is relatively small. And if you have more questions, feel free to relate to that later. But Microsoft Advanced Threat Analytics and Microsoft Azure ATP are actually both brothers to do the same solution. At the end of the day, both of them are actually trying to understand how users behave and to understand whether we have advanced threats, compromised users, and how to analyze them. However, the Advanced Threat Analytics is an on-prem solution. And many people are asking us, so you're talking a lot about Azure ATP, what about ATA? Do you not invest anymore in ATA? And the answer is that we do invest in ATA. And ATA is up and running, and we support it. And you can feel safe to continue to work with Azure, with ATA, and continue to work with that over the future. Keep in mind that we are talking here about Azure ATP, and we are super happy about how we can push an update on a weekly basis, but let's remember that pushing an update on a weekly basis for an on-prem solution is not very easy. Think about Windows Server or anything like that. If it would have been pushed every week, it would have been hard. So the main differences that we have today is that ATA runs in a silo. You are managing that on your own. It's running on a server that you need to run. It doesn't see the cloud identities, while the small brother, Azure ATP, I'm saying the small brother because it was just born 6 months ago, Azure ATP is actually running in the cloud. So you still have the sensors deployed on the domain controller, but you don't need to manage anything beyond that. All of the traffic goes in a secure way to the cloud. And by the way, if your domain controller are not connected to the internet, then just install a web proxy, and those domain controller will talk to the proxy that will talk on their behalf to the cloud. So our solution is pretty much secure, and many organizations working in this way.
Yes.
And Azure ATP will open you to a new world of cloud management, of really being able to connect to Windows Defender ATP, of seeing all of the goods that we've just seen, to connect to Azure AD Identity Protection, to connect to Microsoft Cloud of Security, to bring alerts from Azure Information Protection and all of that. So ATA customers, you have a roadmap, we have a development, we'll continue 1 or 2 development major versions per year. But if you have the opportunities to try Azure ATP, I think that you'll find it more beneficial for you, specifically if you're working with cloud aspects. So let's start to wrap up this discussion.
Yep.
Some resources. Some interesting resources. Technical documentation. You can find a lot of technical documentation. Many of that has been renewed over the past several weeks. We have a star trial. And you can actually, I want to invite each and every one of you to join to our YAML community. In the send us feedback, you can see an email alias, AATP feedback, Azure ATP feedback at Microsoft.com. Feel free to send your messages or feedback if you have ideas, if you like to say to us how much you love the product, or whether there is a challenge or gap or something that you're missing. Use that. Astrid, myself, many people in our team are very dedicated and devoted to this mailing list, and everything you have to say, just let us know. We'll be very happy. So, evaluate this session. We'll always appreciate people who are evaluating the session. It's very important for us. And if you enjoyed this session, show it to us. So with that, thank you, Astrid.
Thank you, Al.
We would like to thank you very much for dedicating 1 hour and 10 minutes of your time. We appreciate that.
Thank you.